So we have to understand the waveguide. It quite long and it takes time to travel from the source to the load. And these reflections are go on happening. Okay, and these reflections are go on happening. Next, go on happening, and the after from the wave which is a reflected wave from the load hitting again with the source, and after hitting the source again it will goes back to the load. So here vs rs by zs. The reflection coefficient at load and source can be defined as load gamma L is equal to ZL minus Z naught by ZL plus Z naught, where ZS is equal to source impedance and Z naught is equal to characteristic impedance of waveguide. ZL is equal to load impedance, and gamma S is equal to ZS minus Z naught by ZS plus Z naught. When we're talking about antenna, it has characteristic impedance. Antenna hand over signal to atmosphere, at atmosphere hand over signal to another antenna. So here input is given to power amplifier is given to transmitting antenna, and the transmitting antenna reaches to air, and that air will again reaches to receiver antenna and hand over signal to LNA, and finally reaches the output. Then if Zs is equal to Z0, that will stop echoes being allowed at the output of power amplifier. If Zs is equal to Z0, that will stop echoes. Okay. Zs is equal to Z0, that will stop echoes being allowed at the output of the power amplifier. Next, the input of the LNA has to be matched to Z node of the antenna. The output of the power amplifier to be matched to Z node of the antenna. Now LNA with no reflections with good matching. The signal is handed over to the mixer. The input of the LNA has to be matched to Z node of the antenna. The output of the power amplifier to be matched to Z node of the antenna. And now LNA with no reflections with good matching, the signal is handed over to the mixer. So low noise amplifier Here the output impedance should be matched to the input impedance of the mixture. That is why transmission line. Here Zs is equal to Z naught into Zs is equal to Z naught, and Z naught should be equal to Zl. That means Z naught is equal to Zl. Uh, Here Zs is equal to output impedance of LNA is equal to Z naught, Zs is equal to Z naught, and Z naught should be equal to Zl. Transmission media and reflections. Wire is a wire. The potential at endpoints are to be same. So here the condition 1, wire should not have resistance. Condition 2, the amount of time it takes for information to travel from one side of the wire should be much smaller. Example, if the wire is small, 1 millimeter length, 1 by C is equal to 3 into 10 to the power of 8. So you can easily calculate that equation. Okay, easily we can calculate. Mm, the transmitting antenna has certain characteristic impedance, and receiver antenna has also having certain characteristic impedance, and also LNA and PA also has certain input and output impedance. These are equal at the chosen frequency, that is omega naught. So here Z in is approximately is similar to Z out, and Z out is similar to Z in at frequency of f at frequency of f. Then at the chosen frequency, the Z node of receiving antenna should be equal to the input impedance of the LNA. Okay. At the chosen frequency, the Z node of receiving antenna should be equal to the input impedance of LNA. Next, let us consider let us consider source with source impedance Zs. I want to transmit something over a medium. Could be air, wire, or anything else, waveguide also. I want to receive across load impedance, that is at the output side, that is ZL. Remember reflection coefficient. Remember that one important thing, that is reflection coefficient, gamma is equal to wave reflected by wave instant. That is wave reflected instance ZL minus Z naught by ZL plus Z naught. So ZL is load impedance, Z naught is characteristic impedance. Okay. So for any non-conducting medium, for non-conducting medium, characteristic impedance Z naught is equal to square root of mu by epsilon, that is mu naught by k into epsilon naught. Here mu is permeability, and epsilon is dielectric constant, that is permittivity. Okay, so mu is equal to mu naught into mu r, epsilon is equal to k into epsilon naught. Okay, k into epsilon naught. For conducting medium, characteristic impedance Z naught is equal to square root of L dash by C dash is approximately equal to or similar to R plus J omega L by G plus J omega C of square root, where L is equal to inductance per M, C is equal to capacitance per M. Next. Here, nothing reflect back from the load. Entire voltage waveform is observed. Okay, there should not be no reflection. So 1T, 2T, 3T, 4T, 5T, 6T. That in case here ZL is equal to 200 ohms and ZS is equal to 100 ohms and Z0 is equal to 200 ohms. So gamma L is equal to, we know that formula that ZL minus Z0 by ZL plus Z0. So 200 minus 200 by 200 plus 200. Phi L is equal to 0. 0 by anything is equal to 0. Next, here there is the possibility of reflections. So here there is a there is a possibility of reflection. So here source 4 by n volts it observes and the remaining 2 minus 2.9 volts are get back to the source and again reflected and again came back to the source, again reflected and again came to the source. Here ZL is equal to 100 ohms and Z0 is equal to 200 ohms. ZL is equal to RL is equal to 100 ohms. Okay. ZL is equal to RL is equal to 100 ohms. So here the gamma, the reflection coefficient is equal to, simply by calculation, all the transmitted or added one time and all the reflected should be added at the another side. So here the reflection coefficient is minus 1 by 3. So the reflect how much part is reflected simply by hitting the load is minus 1.3. The reflection coefficient here is termed as minus 1.3. Next, the condition for no reflection. So, no reflection means there should be the perfect transmission and maximum power will be transmitted from, will be transferred from source to the load. So, ZS is equal to Z0, RL is ZS is equal to Z0, ZL is equal to Z0. ZS is equal to ZL is equal to